come a little closer so we can talk through the lesson, and we, just for the sake of the recording, we highlighted things that were important, and now we're going to talk about it. Okay, so first, even before this, even before they did the getting in groups of, like when you were just talking about it, what did you notice when you were talking about what groups meant?
I liked right away one girl said same number. So she had the concept of equal groups. And then another kid said partners. Which I thought that was good because we don't often refer to partners as group. That's a group of two.
More than one.
And then one said groups of 10.
Yeah, there are five numbers.
Which actually is helpful.
Yeah. I said, what kind of group, whenever I asked them what kind of groups we use every day, and they're like, oh, what we do over there, and I couldn't really think of a name for it.
But I also liked you didn't directly confirm or deny any of them. You kind of left it open, so it's like just their thoughts kind of simmering for a while.
Yeah, they're working on that.
So why is this important? What does that tell us, all these things that we wrote down here? What does that tell us?
They have some experiences with groups, not always directly enough.
Have varied experiences. Seemed like they knew what groups were, right? They didn't have a problem coming up with examples. And then during the grouping activity, we predicted that they would be excited and meet some boundaries, and that there would be leaders. We wanted to notice, were they accurate in forming their groups? What did you notice during the group activity?
Every time I noticed there was this one girl who would say, I need to count you. She was like, because I could tell, I think it was the same person who said same number. And she wanted to be the one, she's like, okay, 1, 2, 3, oh, we got it.
Yeah.
Yeah. What else? Oh, whoops, this was still purple. What else did you notice about the grouping activity?
I think it was easier for some students, and like the groups of 6 were really difficult for them.
How did you know that it was difficult? What did you see?
Well, okay, I saw a lot of students like standing around, like either in groups of 2 or 3, and then it took the longest, and even then they didn't like easily create their groups. They had a lot of help from Carson.
Yeah. What does that tell us? Why is that important?
Well, I don't know if it's because it was like a larger number and it's like the smaller space. Because I think the space kind of did play a role in it. But also they kind of didn't know what to do when it was an uneven number.
Well, it was also interesting because she went from 3 to 6.
Yeah.
And I assume that was an intentional
I
to
thought
see if
they
they could
could
double.
double.
And they, you know what, one group did.
One group did.
And then they split
They
up
kept
and
splitting
did
up, like,
something
1, 2, 3
different.
groups, stay there,
Yeah.
don't move.
Yeah.
Maybe if you had been like, sit down when you have your group.
Yeah, that would have been good.
Yeah, to signal to others.
That's a
That would
great
have been,
idea.
yeah, use that for yours.
Yeah.
I guess I assumed they would just stand there.
Because it didn't make sense for them to just like be like, oh, there's 3 more. But
Yeah.
they kept moving.
Yeah, I like that suggestion. Okay, so then she introduced the problem. We thought they'd be excited and make connections and to their prior learning. We wanted to notice, were they understanding, were they engaged? We wanted to look at their facial expressions. What did you notice when she launched the problem?
Kids gasped when she said
Yeah.
cookies.
Cookies. They were excited. Yeah, I wrote gasp too.
With the 3 and 5 number set, there was a little boy with blonde hair. And he was like, he said, it's so easy to me. I know the answer in 1 second.
Yeah, and he did, actually.
I think
Yeah,
it was that one.
It was him. Okay, let's figure out, when she introduced the problem, they were excited about it. Do you think that they seemed like they understood from when they were sitting on their carpet, they got the idea of what they were supposed to do? Any clues from their faces while they were still sitting somebody said it's easy, right? So I
Mhm.
guess that is evidence.
And
It's
they
so
were all
easy. Yeah,
They were all looking at me, so I could tell,
Uh-huh.
or at least had their eyes.
Looking at T, okay. So why is that important? What does it tell us?
They were engaged.
Yeah. They were certain, like, they were into it. They
Mhm.
were.
Your
love
class is
that.
so quiet.
That was awesome. They normally like to like talk to their partner, but I think having so many people around.
Yeah.
Yeah.
I'm sure they
I
did.
heard one said 6 teachers?
Yeah,
Yeah.
I'm sure. That was a little overwhelming.
Yeah.
Okay, then you let them solve for 3 minutes. 3 minutes was a long time. It felt like a
It
long
was.
time.
That's mostly for me, so I can
Yeah.
select which students' work I'm going to share.
Mhm.
Because I had trouble deciding because I saw some of the same strategies, so I had to pick like two examples of each. That's why I didn't share 3. I didn't say
Yeah.
a third example except for the standard algorithm. So
So we thought they might need clarification from you. We wanted to be noticing which strategies got used the most and were there any, we kind of predicted that there might be that misconception of adding which 3 kids?
yeah, a few of them did.
Yeah, I read that in a few kids
Or
with
they
3+5.
they had the idea, but their number sentence was incorrect. Like they knew what they were doing, they just didn't know how to write it.
There were some that
I
didn't.
saw
And
some
there
that
were
didn't.
two, like, so one thing I noticed was, okay, there were 2 kids at least that had the 3 + 5 = 8, right?
Yes,
I
definitely
saw
And
that.
they drew it that way
Uh-huh.
too, so it
Mhm.
wasn't
I saw
that
a
they were.
student
like,
subtract.
just didn't know.
I saw
Did
that
you see a
too.
subtraction?
Yeah.
Someone with last name Martinez
No.
said that, you know,
It's like a subtraction problem for
5
this.
minus 3
Yeah,
equals
Yeah.
2.
yeah.
And
And
then
then
I
I
also saw, for the 3-5, I saw a 3-5.
Yeah, I saw
I
3
did
plus
see
5
that.
equals 35.
Yeah.
Yeah, definitely need some small group.
But that was the minority,
Yes.
right? So we had maybe 4 kids.
I put 4 that were adding,
Yeah.
but
Yeah.
could have been wrong.
So 4 adding, does that include the subtracting guy or?
No.
so- And so then there were 4 adding plus the subtracting guy plus this one. So 6 kids that,
Mhm.
But you always
Or-
have 3? I could have miscounted, I don't know.
it's okay, well.
4 to 6
Three
is
is
about
She can check
typical.
out their
Yeah.
papers to
Right.
see what it is, so we're gonna have this group that at least initially didn't get it, but then we can think about what they did later on, because I think some of those corrected their strategies later on after
I know the subtraction girl did not, but
it was not.
Going along with kind of some self-corrections, there was one student, I watched her for a while, and she kept starting a valid strategy, and then she would erase it all. And so she tried a whole bunch of different ones, but never really settled on one. So she started with doing a direct modeling, actually drawing, then just wrote the number 15, then erased, then started 3 plus 3, erased, and so kept kind of backing up from what she was trying.
Mhm.
did you look at her name tag?
Yes.
Oh,
Mhm.
yeah. Yeah, she didn't even finish, and she's usually in the.
She just kept erasing. It was very interesting.
Very like second guessing.
And then we saw lots of kids who really did get it, right?
Mhm, absolutely.
And what kinds of strategies do we notice here? Direct modeling.
Mhm.
I was really impressed with the girl who wrote, what did she do? I wrote it on here. Oh, she's the last one you had to share. So for the 12, she wrote 4 groups of 12, but then above each number she wrote 12, 24, 36, 48. And was she the one who was adding on her fingers? Is that
She
what-
solved the challenge problem by
Okay,
adding
yeah.
on her fingers.
I was
Not
so
even
impressed.
personally.
I don't know why. I was like,
She's, yeah,
Yeah.
I was impressed.
well, just being able to write it out every step of the way so you don't have to go
And
back
it's
and
correct
count
too.
it.
A lot of
Yeah.
them will draw it and then they don't draw a circle or they just miscount
Yeah.
and it gets
Mhm.
off, but she was spot on.
Mhm. There was one who, on your challenge problem, started out and did 9s in circles and, sorry, I'm sorry. And then broke down, would slash the first
Oh,
9, then broke down the second 9 into 8 and 1 to give that to this 9 so she could
Yeah.
make it into 10s. That was some
I
complex,
Whoa.
Yeah.
interesting
I don't think
thinking.
she quite got to the
Did
answer.
she not?
But
Oh.
she was
No one ever finished.
really working on it for a long time. Let's stick with this first time, so
Oh,
the
yes,
first
sorry.
3 minutes. So what do we take away from all of our observations during that first give it a go?
There were some misconceptions, but also some kids definitely were able to figure out some strategies on their own. And it showed that Carson didn't really lead them into doing one strategy because they were able to come up with different ideas on their own. Like if they had all done one thing,
Right.
it would have been obvious that they like had gotten the idea from something.
Yeah, different strategies. That is important. Thinking on their own. Okay, then we had that first discussion. And look at your notes from what happened there. Anything that we thought, what would be the most common? What did we notice about that? Like, which one did you find was the most common?
Drawing it, direct modeling.
Direct modeling?
I like that you pulled up a direct modeling where they didn't do the whole thing right, that they wrote the number sentence wrong, and because then they were able to show the correct direct modeling, but you were able to have, like, lead them to figure out that they hadn't written it right.
Yeah, a lot of them had that misconception, so I wanted to tackle that.
Yeah.
I didn't realize we would be encouraging them to use like the
I
multiplication
know.
symbol.
That was a surprise.
But
Like,
knowing that it means groups of makes a
Yeah.
lot of sense.
Yeah.
Instead of saying 3 times 5, that means nothing.
Right.
3 groups of 5
Yeah.
means something.
Have y'all said that before, like with the multiplication symbol, I said groups of before?
Mhm.
Okay, that's what
I think they did it on Wednesday, right?
They had it before,
Had they?
but
Okay.
not very often, I don't think. But yeah, we tried it on Wednesday.
And why is that important? Because groups of means something.
It's kind of a teacher move thing, but you're very careful to praise each student, and I could see on their faces after you praised them, they're like, okay, I'm walking away and I'm standing tall, so it was
Yeah.
good. Built their confidence even if there was a correction that was made as a group.
Yeah.
Oh, you also brought back your schema. In your first
Mhm.
discussion, you said something about how when you were asking if they used a different strategy and no one would respond, you
Mhm.
said, okay, can we think about what we did at the beginning? Like about the table groups or something, and you brought back the counting, or like the groups of 5, so, sorry, that was.
No, that's good. Brought back counting by 5s. Yeah, because that was something in that grouping activity that like right before, right at the end, somebody said we can count by 5s.
And you guys all counted
Yeah.
by 5s?
Uh-huh.
Yeah, yeah.
And I wanted to keep going.
Yeah.
I have a question just for my clarification. What was the symbol that one student was thinking of when he thought there was another?
Division symbol.
Division symbol, okay.
It
I
was
was
just
just
kidding
curious.
for division.
Yeah.
Because he had written division on his paper.
Uh-huh.
Oh, I
We
hadn't
talked
seen
about that.
before.
We wrote the wrong symbol the other day, and when we
Okay.
addressed it with him, we showed him that the time symbol is groups of,
Mhm.
but then Ms. Benson showed him the division symbol, like, this is actually what this means. You're dividing, you're
Mhm.
taking parts, and then he was like, okay. And then I guess he just
Yeah.
forgot.
Okay, I was
With-
just curious if
Yeah.
that was about.
And I think you addressed it in a way that most kids who were ready for that got it. Like, I'm glad you didn't show the division symbol. I heard you talking to Ms. Benson about should I do that? Because that just gets one more thing
Yeah.
in kids' heads.
I'm glad I
And
didn't.
that's fun. Yeah. Okay, so from this first discussion, we knew that direct modeling was the most common. What else? What was the other strategy that you had them demonstrate? What did the other kid do? Oh, it was
They just
like
drew circles, but put 5 and 5, or 5, 10, 15. So just using numbers, but also using like
Yeah.
groups.
For the group,
Right.
Yeah.
but-
Just not drawing circles, that takes
Mhm.
forever.
Mhm. So why is this important? You just kind of said that it takes forever to draw the circles, so.
We're
this one-
teaching kindergartners about being efficient mathematicians.
Mhm.
Yeah.
So-
Efficient.
and you brought that back and you were like, that takes a long time.
Yeah,
Yeah.
whenever the girl drew like all the circles
Mhm.
for 8 groups of 10.
Mm-hmm.
I saw a lot of kids doing that too. It takes forever.
Yeah.
Then they sometimes will miscount them or draw 9 circles instead of 10.
Some kids, this is more like on the red, but some kids did the answer and then went back and showed the work.
Mm-hmm. Because they know like we will ask them about it if they just write 15 for the answer. But I don't know
Right.
really what to do about that.
Yeah, and I think, well, they had time for it, they knew that they needed to see their work. That resulted in more kids having direct modeling than actually used direct
Mhm.
modeling, right? Because some kids went directly to the equation.
3 groups of 5.
Some kids,
Which do you think they did the process in their head, or
Uh-huh.
do a couple even have fact fluency with it?
Yeah.
Because there's that
Some
one that I was
uh-huh.
like,
A few of them do. They can do just do it in their head.
Or they might have just in their head gone.
yeah. Yeah.
10, 20, 30, 40, 50. It's harder with the 4 and 12 though.
Right.
Mhm.
I think a lot of them did the first two, like just wrote it out, and then they were like, oh,
Oh.
now we need to draw circles.
Yeah.
Right? So what does that tell us about their thinking? And like next steps. So maybe thinking about why is that important for next steps? They quickly solved a lot of kids quickly solved the 5 and 10 problem. But the 4 and 12 one, and certainly the 9 and 12 one was different. So when you think about next steps for kids, what kinds of problems do you think might be beneficial?
Think what sort of number sets to
Uh-huh.
give them. Maybe something that's not quite as simple as 5s and 10s. Something that's harder to
Yeah.
comprehend. Or maybe doing different groups, like keeping some students with 5s and 10s
Yeah.
and some students moving on to, like the student who shared the challenge problem, giving her something
Mhm.
different.
Mm-hmm.
And she was spot on.
Because
Yeah.
these 6, wherever they were, these 6,
Yeah.
they, you don't want to give them, like,
No.
they can do 5s and 10s and help them get the concept, maybe.
Mhm.
Do you ever give them like manipulatives to work with?
Not typically, they draw it mostly.
Right, maybe for like those 6 students who are
Mhm.
struggling, it would be helpful.
Like
Yeah.
that.
Because I know you don't need 80 Unifix cubes, like,
Mhm.
you know, but.
With the small number
Mhm.
problems, just so they get the concept.
Yeah.
Yeah, that's a great idea.
I also wonder for some of those students if they just didn't understand the context it was referring to, especially the subtraction one. So that might be something to consider in the future.
Well, so thinking about your math lesson that you're going to teach, I know you had talked about maybe showing them a visual. Meredith talked about that too, like having a visual for them to see what it actually means by groups of.
Yeah.
And you were going to show them a picture of the bus,
Yeah,
right?
Inside of a bus. Mhm.
Yeah. So
But it's not like, it's not gonna be like kids on the bus, it's just so they
Right.
can like see what I'm talking about.
Yeah,
That's
I
a
think
picture.
for Meredith, she's actually gonna show a picture because they're
Like
5 and
this.
6 years old.
I'm gonna show some ladybugs and then I'm
That'd be
gonna tell a
concrete.
story. I'm gonna be like, I was in my mom's garden and I saw these 2 ladybugs on this flower and then I looked over and there were 2 more ladybugs on this flower. So.
That's perfect.
And yours has a story to go with it too, because it's about your field trip that's coming up. So kids on the bus, but I think having that picture of the bus seats is gonna help them like not go to this kind of a strategy.
Mhm.
Even though they're more advanced, they probably wouldn't go to that strategy, but it'll help them maybe go beyond that. and understand the concept a little bit more. For these 6. Everybody else probably
Yeah.
had the concept, but these 6, we need to think a little bit differently about them, with the manipulatives and really giving the visual. And you all are gonna have these 6, like maybe not 6, and maybe not exactly the same issues, but you're gonna have a broad range when you teach this lesson. Okay, then we gave them time to solve the remaining problems. What did you notice? Did anybody go back and correct their work? If they had made a mistake the first time? Did anybody use a different strategy?
I saw that Carson met with one student who was still adding, and she was like, well, can you draw that for me? Can you show me what you did? To help correct that. And she did it.
With the little boy.
Yeah.
Yeah, 'cause he can do it, he just needs some guidance, yeah.
There was also a great conversation that I listened to there was a boy sitting close to the kidney table.
Yeah.
And I tried to track it as much as possible, but she said, okay, how could you figure out 8 groups of 10? He was kind of like,
He just kind
and
of
he'd been counting, and he's like, count all the circles, or maybe, sorry, you said count all the circles, because that's kind of what he'd shown already.
Mhm.
And he's like, yeah, and she's like, that would take a long time, wouldn't it? And then it ended up pushing him, so like, how can we do this faster? And he ended up counting groups of 10. So
Oh, he
counting
did.
10s.
Nice.
Yeah.
So pushed him really well in a very
Mhm.
short amount of time.
Yeah, he's the one that relies on the number line for adding and subtraction,
Mhm.
so when he can't use that,
Mm.
he's kind of lost.
Gotcha.
But he had the correct strategy, he was just stuck on like, so where do I get my answer from?
Right.
But,
I also noticed Hope, she was one of these 6 in the first problem, but after the discussion, when she went back, she did 8 times 10, she showed her direct modeling.
yeah.
So she changed her strategy based on the
Mhm.
discussion versus adding.
She was one I wrote down. You might want to look for this on her paper because I saw and I couldn't tell the order of when things had happened, but
Mhm.
when I looked at it, had 3 groups of 5 equals 15, but then 35 in
Yeah.
a circle.
Right, she did that.
That was,
This was her first
Okay.
attempt, and then she did go back and fix it.
okay, it was at that point that
Yeah.
I saw, so I couldn't tell where she was in the process, and I
Oh,
was
yeah,
able
Yeah.
to
she
circle
wasn't
back.
the adder, she was
The
this
35.
person.
Whatever
Yeah.
that was.
Yeah. So, why is this important? This is actually the most exciting thing, right? Because they learned
Yeah.
something. What did you say?
I said they're like self-monitoring, so
Yeah.
they're able to
Yeah.
see what they're doing and adjust if needed.
It's helpful for me to know which students have got it and which ones I need to push, which ones
Yeah.
I need to work with. So just future instruction.
Yeah. Oh, this was something really interesting on the solving of the remaining problems. So, the boy, I don't think I ever got his name. You know where I was standing a lot of the time over toward the front of the room, but on that one side? So here's a group of 4, and he was right here. Like, this guy closest to the.
That was the little blonde one?
No,
Dark
the
hair.
dark hair. The blonde was over here and then
Oh,
he was
okay.
right across from him.
Oh, yes, Johnny.
Okay, so he had drawn, okay, the challenge problem was what? Was it 9 groups of 12?
12 groups
or
of 9.
12 groups of 9. And he was counting by 12s. And he had done it incorrectly, like counting by 12, so he ended up with 148 or something. But anyway, Miss Benson came over and said, tell me how you did that, and he said, I counted 12s, and she said, so look at the problem again, what is it telling you? It's telling you 12 groups of 9, so does that change how you're going to think about it? And so then he started counting by 9s. But I thought it was interesting because we had actually, both times we had kids who like did 10 groups of 8, and 8 groups of 10.
Interesting.
And then, yeah, and then somebody noticed that at the end, like, when Hope was up there, okay, she did 10 groups of 8. She had 10 groups of 8 that she had modeled, instead of 8 groups of 10, I think.
Okay.
And then one of the kids said she could have used 10s and counted by 10s. So they noticed, one of the kids actually noticed the flipping. So some kids, I think, are almost ready to think about that 8 groups of 10 ends up with the same number as 10 groups of 8. But that's more of an extension for some kids. I thought that was interesting, that some noted the commutative property. Okay, and then from the second discussion, we kind of already talked about that. So that was like noting the commutative property. Anything else that you want to say about the second discussion?
I think it's harder to get kindergartners and first graders to talk to each other, but I think you did a really good job when you were like, well, can we help her think of another strategy, just inviting students to like be a part of the discussion.
And did anyone else do this?
Yeah.
I noticed the second time, because they had their papers in front of them, they were a little more able to know whether they
Yeah.
actually did a different
It's hard for them
strategy.
to think.
Yeah.
And they were playing their papers.
Yeah, so there are pluses and minuses
Yeah.
to having the paper.
Yeah.
Do you think the pluses outweigh the minuses? Is it worth having the papers on the carpet?
I think so.
Why?
Because they're able to actually remember what they did and talk about it, because they have it right in front of them, instead of having to think, did I do that?
And there could be some sort of instruction, where you say, put it on the ground in front of you and
Yeah.
hand up.
Yeah, they just normally don't have paper on the ground.
Right.
Right.
So that's something.
But it was fine, it wasn't like a huge
No.
distraction, I only had to correct them one time.
Okay, and then the turn and talk at the end.
I had a really hard time hearing kids.
I leaned in a lot, and like, there were kids saying, I tried my best, this was so
Mhm.
hard, I learned a new strategy.
Yeah.
A lot of the same things that they came back
It's
with. when
definitely,
we did
like,
whole
this was
group.
really hard, but
Yeah.
I tried my best.
And
I love it.
I did notice, I wondered if you had a student absent today perhaps,
Mhm.
because
He came
in
in.
the back right, there was some confusion of who was in what group. And there was a little boy, in the first turn talk, a little boy with brown hair was kind of looking around.
Yeah.
And then there was a
There was a
little
kid that
blonde
came
boy.
in late.
Okay.
Mhm.
And
And
then
he
the
just
little
joined
boy
the
was
last.
talking to himself about his strategy.
Yeah.
He normally does.
That was okay.
Yeah.
He's okay with talking with himself, right?
Loves to self
Yeah.
reflect.
I heard one kid said, I learned, when they were talking in foreigners, he said, I learned about adding.
Oh.
And then,
Just adding.
Oh,
Adding
repeated
words.
addition.
okay, I guess that's what he meant. He said,
Hopefully.
I learned about adding, and then the other kid was trying to think of what he, or like how to phrase it, and then he said about the other kid, he said, I think he's trying to learn.
Oh.
Well, and Caitlin
spoke
told
for
me
him.
that she learned what it means to show groups of, but she couldn't remember what she told me, and it was so good.
Yeah.
I tried to rephrase it.
Which was really important, because she's the one who was adding at first,
Mhm.
right? But so she had an important insight.
She did. She just couldn't articulate it.
It's a lot of pressure
Mm-hmm.
when you're a first.
Then I talked to Corey, who sits right in the front. He said, I learned that we have a few days left of school.
Oh, no.
Oh my goodness.
He's all over the
Okay.
place.
Wow. Why is this stuff important? All their comments in the closure. What does it tell us?
It's feedback for me if I know that they learned something,
Mm-hmm.
or how they feel about what they learned.
Yeah, it's just their
And what did you
perspective.
learn about what they
I learned they persevered.
persevered?
I didn't have any of them just completely give up.
Yeah.
They were
excited
so
to see.
good.
Yeah.
A good group.
They
Well,
are really sweet.
it's a good lesson. We planned a good lesson, right? That's why it's so awesome. Okay, so, as we look